Hello, everyone. Hope everyone's having a good day today. So, as mentioned, I'm Jonathan LeBlanc. I run global developer operations over at PayPal. For the last 10 years or so, I've built my career off of the identity industry, off of data mining, data security. It's a passion of mine. It's an interest of mine. And around 6 years ago, when I joined PayPal, I found these deep integrations within the payment security industry. So it's fun to talk about the payment industry when it comes to security, because a lot of it is based off the same open source technologies that I have worked with for the last decade or so, which makes it incredibly fun. So what we're going to be talking about is really how the payment industry is evolving, how it's looking at identity, how it's looking at security, and really what the next steps are in the industry. And this is an opportune time to be talking about this, because around 10 years ago, 10 years back in January, the iPhone first launched. I remember this date quite clearly. My wife bought the first generation of the iPhone. And I was saying, why the heck would anyone want a phone that has all their digital lives in there, where they can build all these applications? A phone's for making calls. And at the time, I was going as small as possible with my phone. I was having this phone going down to that level, with a nice little Zoolander type phone going on right there. And so after a couple of years of seeing the industry build around the smartphone technology, I could say that I was completely wrong. My wife was completely right. Please do not tell her. So it's amazing to see how the mobile industry has grown around that. And when we're talking about that, I like to show it in numbers. And not just any numbers around, but numbers in comparison to other things that we have on our day-to-day lives. So let's take a look at what that looks like. Back in 2013, there were more cell phones in the world than there were people with access to toilets. That's amazing when you think about it. Something that is so core to us, to our general lives. More cell phones than that. Back in 2014, we hit an interesting jumping off point where there were more cell phones in the world than there were people. So when the devices finally take over, we're all outnumbered already. But that was back in 2014. As we skip forward, 2015, more people with a cell phone in the world than a toothbrush. And that's what I like about numbers like these when they're released, because they give us a good perspective on what the mobile industry is looking like. And in 2020, it's projected that there will be more cell phones in people's hands than people with electricity, more cell phones in people's hands than people with running water, and more cell phones in people's hands than there are cars on the road. That's impressive. But this is the current. This is where we are right now with the industry. It has become an essential part of everything that we do in our day-to-day lives. So it's always interesting to me when I hear companies talking about a mobile-first approach, that we should have mobile SDKs, that we should have a mobile strategy. It makes no sense, because at the end of the day, it's just a strategy. It should be synonymous of what you do and everything that you're integrating. But when you look at the mobile industry, there's a reason why we're talking about it right now. And that's because of where the future is going with connected devices. And this is the only time I'm ever going to say the words Internet of Things. I dislike the marketing term, essentially for connected devices. That's all we're talking about here. And this is where the industry is really going towards payments, towards pretty much everything that we do in our general lives, is taking contextual information of where we are, our location, what we're doing, our payments, payment options that we stored, and doing something with it, and trying to do it securely. Now, unfortunately, within that IoT industry, I said it again, within the connected device industry, the security usually comes last, when it should be part of everything that we're doing. And the reason why the IoT industry is so tightly tied with mobile is because as connected devices were released, they had centralized hubs that they were working off of, that they were building off of. And companies were fighting to be that central hub, when realistically, connected devices should be tied to a centralized hub that we already use. If you try to push another piece of hardware on someone, it's really doomed to fail unless it becomes part of their general lives like mobile technology has. So the cell phone as the hub. And when we really look at the IoT market, we can see where that's going. So in 3 years, around 2020, IoT vendors are expected to top $470 billion for hardware, solutions, and software. Quite a high number. So that's from Bain. In 5 years, we're expecting nearly $6 trillion will be spent on these solutions, on IoT solutions. Then, as we're going 10 years out, we're going to see the makers growing from 15.4 billion devices in 2015, so where we were. In 2020, 30.7 billion, and then going into over 75 billion by 2025. This is the market that's building out within connected devices, and it's like the Wild West of development right now, which is the most impressive bit. In 15 years, investment in this industry is expected to top $60 trillion. Now, it depends on the conservative estimates that you're looking at, but that is an incredible amount of money. And really what this means to all of us is that we have created an entire new generation of inventors. When I started doing hackathons around 10 years ago, I remember doing some of the first university hackathons that we had. And I would see software solutions, web solutions, pretty much any solution that you can think of that was computer science related. But the hardware solutions always impressed me because it's something that I couldn't do. It's something that I didn't study. And I remember one case where a hacker and his team, he brought in a mini-sized fridge, medium-sized fridge, and brought in all these pressure plates that he put inside the fridge that could measure the weight of anything that was put in there, and then built out some boards that would communicate to a web endpoint to be able to track on a mobile device so that he could see what's in his fridge. The reason he did this was because his roommate kept stealing his food. So it was an impressive solution, and I was enamored by the technology, but I couldn't do it. I didn't have the skill set. And that's where this industry, the connected things industry, microcontroller, small-scale computing, it gave a lot of us within the computer science industry that aren't traditional hardware engineers the chance to be inventors. And prototyping started mainstreaming. So what you're seeing on the screen now is a bot that I built out, and you're probably saying right now, why is this stupid bot running into walls? But essentially what I did was I 3D printed the shell, added a couple RC parts, connected it to an Arduino that would have a web connection, and had a USB receiver on it so I could use one of my old Xbox controllers so I could wirelessly control it. This was built out for a demo at an event so that people can run it through someone's house, and as you start hitting walls and trashing the person's house, it'll automatically send a PayPal payment out for trashing their house. Stupid solution, but the entire purpose of it was to show the tie-ins of secure payments within the connected realm of devices. That's all it was. And this leads us down to the area of contextual commerce. Now, as I said, within connected devices, our entire purpose is to remove a lot of the issues in place for people, is to get location-based data, is to get their payment details, and be able to push them through that process incredibly easily. That's why beaconing technology happened with Bluetooth Low Energy. That's why we're seeing a lot of hardware-based solutions in shops now, is all to remove a lot of those interaction hurdles. So contextual commerce as a concept is all about allowing people to integrate with these connected devices, integrate with a mobile environment, integrated with a web environment, any single environment that they choose to be in, and have a lot of this information known already. Have a lot of this information readily available so that I know your payment information, I know your address information from what you've set up, I know how you like to pay, when you like to pay. Why the hell would I push you through several screens to ask you the same information? It's like early on, filling out job applications and then uploading your resume and then having you fill out every single form over and over again. It's stupid. Why would we do that? And that's the entire purpose of contextual commerce, is to remove a lot of those hurdles. And at the same time, applications need to be smarter. They need to know more about you. They need to have the ability to make these decisions for you. But that's where the security aspects come in. How do you secure these payments? So let's say you're sending in voice-based payments. You're sending in some credit card details through one of these connected devices. Well, you're sending in that information through the clear. You're not encrypting the data. And now anyone can sniff the channel. You have a hardware solution. One of the biggest problems is that you have a hardware solution. Anyone can grab that hardware solution. Anyone can sniff that connection. It's the exact same problem that beaconing technology had early on, was that you deploy a solution, but any single person can actually connect to the beacon, see the traffic. So the concept of securing payments within unsecured channels actually comes into play. And when I first moved to the US back in 2005, I had joined this environmental engineering firm that worked for the US Navy and as general IT. And if a lot of you in this room probably know what general IT means, I was hired as a database administrator, but I fixed everyone's computers. I created networking cables, and I strung them through the ceilings. I did pretty much anything that needed to be done. And something like this is very painful to see, so for the sake of the talk, and just as a small caveat, I'm going to put that puppy up there so that we have a calm and serene next talk. OK, so the concept of unsecured payments is to actually work within these connected devices. Work with devices that potentially have no security whatsoever. How do we transfer any privileged information through those? Well, first, one of the things that we can use is a technology, an open source base that we already have, which is key cryptography. So how many of you here have worked with OAuth, OpenID, JWT, or any of those specs? Yeah, that's pretty much what I thought. A lot of you. Key cryptography is just based off single, either a public key and a private key in the case of asynchronous cryptography. That's great if you have no control over the endpoint. So let's say a device endpoints that you have no control over, it's good to use multiple keys for the cryptography. Or you can do synchronous cryptography, which is a single shared key. It's great for environments where you, as the deployer, own both ends of the spectrum. And that's going to essentially encrypt the channel. But if we're looking at the payment industry, if you don't have encrypted channels, if you have mixed channels that are out there, some of the things that you can do are actually leveraging off of technology that's become very interesting in the payments realm right now, which is tokenization. Now, what tokenization is, in essence, is taking that privileged information, such as address details, credit card information, pretty much anything that you can think of on the privilege side that you would never leak out, that a government might want you to regulate. And what you're doing is you're storing that in a secure vaulted location that is PCI DSS compliant. It might be something that you own. It might be that you are storing it within a solution like the PayPal Vault, which is in essence storing your credit card information, and passing back a secured token. So all you're dealing with is a token. And the industry is already building out with these specifications. So Apple, Android Pay, basically every single bank or credit card company is utilizing or trying to build out this type of specification. They're building their own pay version. And it always seemed like a proprietary approach to me until I started reading the EMV payment tokenization specification, which is the underlying technology and specification for understanding how this system actually works. And when you look at it, it's not all that complicated. This makes it look complicated, but it's not complicated. So you have a customer, and the customer is going to go up to a point-of-sale terminal. So they'll go up to a merchant. They'll scan their phone, which has that token baked on it. When they signed up for whatever application, or let's say a pay version, they're given a token. In the case of most of these tokens are long-lived, 3 years. is the typical standard. They can also be short-lived, which is one-time use tokens. Now, the point-of-sale terminal, when you scan, is going to communicate with the credit card company in essence, to leverage it off of their network. So communicate with the credit card company. They're going to look up that token in their token vault. And behind the scenes is a number called PAN, which is primary account number. And that PAN is what's going to be sent to the bank to verify your account, verify whether you have funds. That's the number that you don't want to get into anyone's hands, which is why it's stored in the vault and why we look it up based on the token. They'll communicate with the bank. The bank will say, yes, they have funds. You can proceed with the purchase. And they'll hold the funds, send the communication back up the line, payment goes through. That's in essence how it works. Now, most of us aren't banks. Most of us aren't credit card companies. So this is completely useless for us in the connected world, until we start ripping it apart. So we get rid of the bank. We get rid of the credit card acquirer network. And all we're left with is a solution that we can use within the connected commerce realm, within connected devices. So our merchant doesn't have to be an expensive point-of-sale terminal. It can be any piece of hardware that you stick there that people can communicate with their phone. Have an NFC reader built into it that can communicate out. Our network is essentially our back-end service that piece of hardware is communicating securely with. We can have our own vaulting system set up. We can utilize external services like what PayPal has in their vaulting system to store the credit card details if we don't want to have to deal with the PCI DSS compliance regulations. And that's, in essence, how the tokenization system can work within this connected realm. Now, on the phone where that token actually lives, and we can look at the specs that they currently have. So Apple builds off the secure element. Android Pay did for early iterations until the phone manufacturers started building their own payment versions and started restricting a lot of access to the secure element. So they work with something called host-based card emulation. It's essentially emulating a credit card that can validate via the LUN algorithm, which, if you're not familiar with, is the way of validating credit cards, LUHN. And then it's going to communicate with its own servers. That's the way that you'd essentially be working. If you need to mimic a credit card, that's the specification that you can utilize. You need to communicate beyond that, that's when you start leveraging off of your own servers. Think of the hardware as a bridge. Now, let's get into the fun beyond this. Now that we're talking about the security aspects of the channel, now comes in the other piece of the puzzle in contextual commerce, knowing who you're dealing with. And that's where the identification fun comes in. So, in order to identify a human being in the world, according to EFF.org, who has done a lot of research into being able to identify people and research projects into it, it requires 33 bits of information. They call it 33 bits of entropy to identify all people in the world. Now, when it was created, there were around 6.5 billion people in the world. I believe currently there are 7.5 billion people on the planet. So to identify those people, 33 bits. This is the formula that they created in order to be able to define that, in order to be able to build this in programmatically. Essentially what it is that S is a reduction in entropy, a reduction in that 33-bit value as a cutoff, or whatever cutoff you want to put in. And that's measured based off of the uniqueness of a particular fact. Now, it doesn't make sense too much based on this, but let me show you some examples. So if we have birth date information, if we have a birth month, so let's say December, we can assume that that's a 1 in 12 chance that you have that birthday. Statistically, you might say that some months have higher based on global trends, but relatively it's going to be around 1 out of 12. You can safely justify off that. So if you're measuring 1 out of 12, that gives you 3.58 bits of entropy based on this value. If you know more information, such as the date of the month, then you can use that based off the number of days in a year, and that gives you this 8.51 bits of entropy. Now, it's not just adding these values together, because it's all about measuring unknown values that you can actually verify. So the 8.51 bits is what you can utilize because it's the highest number. It's what you want to utilize. But then the first number becomes useless because it's already known within that second equation. Location-based information. So let's take Santa Clara, Santa Clara, California as an example. So I have some numbers on that one. If I have a zip code or a postal code or what have you, the zip code in this case is 95123. There are, when I looked it up, around 65,000 people within that zip code. Based off the current number of current population of the planet, that's 16.81 bits of entropy. The city of Santa Clara, if we're at that, that's a higher number, 122,000, 15.9 bits. California's around 39 million people. Based off the current population, that's 7.58 bits. So as you can see, the more information that you have about a person, the more it can add up. The more you can get to that magic 33 number. Realistically, you'll probably want it to be a little bit higher, just to validate, especially when you're dealing with privileged information like payments. One of the things that EFF.org created as well is this interesting research project. They wanted to see how the entropy follows suit to browser identification. So if you're on a laptop, if you're on a computer, browser fingerprinting becomes interesting because what it's measuring is browser uniqueness based off of information that you can get through JavaScript, like the user agent string, like the cookies, your font set that you set up. All this information can be pulled and used as a unique value so that you can identify one in X number of people that has that same browser set up. Then you can utilize that as a point of contact for that individual so that you can identify that individual based off those values. Now, in the mobile world, in the connected device world, what you're going to be dealing with is device identification, or device fingerprinting. Essentially what this is pulling out a unique value within the mobile device, a piece of hardware, because all of them will have a unique identifier if they're connected to the web. So what we can do is something like with Android devices. We can pull build information. So pulling the build information will allow us to get device, model number, elements like that, serial number. That particular one is deprecated, so there's a method called get serial that'll pull the same information. That becomes a unique identifier towards the person. Now, one of the questions that usually gets brought up when I talk about this stuff is, well, what happens if I switch phones, or I switch my browser, or I switch something? Well, all this is doing is removing the hurdles from the user experience. So let's say can I uniquely identify my user and the browser they're using or the device they're using. What I'm going to essentially do is offer them something like a one-click payment or a voice control payment. I have their credit card information. I have a way of paying. I know how they want to pay. I can just purchase directly for them. No need for them to enter those details. If I cannot uniquely identify them or I can't hit that entropy level, then I throw hurdles in their way. Then I throw logins. Then I throw verification of address information. So it's all about building trust zones. That's what you're doing, getting down to the point where it becomes incredibly easy to interact with the world around you. As we're looking at uniquely identifying the user, date of birth information, anything that you can verify through the credit card information, that's one source. Then we can also use location awareness, something that we've been using for a very long time to identify a particular location where the device is being used. If, for instance, I have a person that is always purchasing through a rural location, spending 100 to 300 euro every month, and it's like clockwork. I'm seeing those same purchases several times a month on the site. Then all of a sudden, I see a 10x spike from a completely other location in the world. I'm going to flag that. I am going to throw hurdles in the way. I am going to provide security mechanisms in order to prevent that account from being broken. That's what it's all about. Now, this interesting study, and I know we've all seen a lot of reports around this, purchasing history. 4 purchases on a credit card can uniquely identify 90% of people. We've seen this through brick and mortar stores as they're looking up users' information and providing couponing through. So a store in the US, Target, is able to, years ago, determine pregnancy state down to the trimester very accurately. Worked very well for my wife as we started getting coupons when she was pregnant. On the device realm, we can also go even further and start getting paired devices information. Now, paired device information will allow us to tie into everything that's Bluetooth connected or any other connected devices that we have. Being able to pull those device identifiers is another mechanism for securing that hardware realm, those devices that we're connected to. So with all this said and done, really where the world is moving towards in the payments realm is removing the hurdles from the buying experience. We have this concept of contextual commerce, which is tying in this identity and security realm within these personalization aspects into the devices of the future, which is a lot around connected devices, where we can essentially secure any sort of payment realm that you wish to go into, wish to build into, and do so in a way that removes a lot of these hurdles from the payment experience. That's everything I had to say. Thank you very much for everyone for joining me today.
Thank you.
Thank you very much.
Can you hang around for a couple of questions, maybe?
Absolutely.
All right. So, first of all, we have a question from Andreas. He says, why not just use Bitcoin?
So Bitcoin is one of the mechanisms that I get brought up a lot, usually within the payment realm. And why not just use Bitcoin? So that's why all the payment industries are integrating Bitcoin wallet systems. One of the chief issues early on with Bitcoin was around security. With Bitcoin wallets, that's where the security is being beefed up. It's the exact same reason why PayPal, why Braintree, also part of PayPal, integrate Bitcoin as a payment methodology.
OK.
It's another payment mechanism. And if you go into blockchain technology, then it opens up a whole other realm around identity and security.
Very good. All right, and one more I have here is asked in a couple of forms, Max and Tamash. Any kind of privacy issues that you see regarding device identification?
Oh, absolutely. So when you have device identification, most governments, and I'm originally from Canada myself, so we have very tight government regulations on identity and data privacy. Most identification aspects need to be anonymized, or they need to be stored for only a particular amount of time. And the companies usually have to be upfront about it. I believe most countries in Europe have the same privacy policies. So it's working within the privacy policies of what's possible within the country that you're working in. Typically, you want to anonymize the data as much as possible, try to secure it as, well, you always secure your information within your own vaulting system, your own secure systems. But that's why things like PCI DSS compliance is in place, so that we're protecting the hardware and protecting people's underlying identity and security.
OK. Thank you, Jonathan.
Thank you so much.
OK.